4.4 Solving system of linear equations with three variables. So when we talk about system of equations in two variable, they are lines, so it's on two-dimensional. When we talk about system of equations in three variable with three equations, now we are talking about in three-dimensional. So each equations represent a plane. So like before, we will have three different type of solutions. As you can see, each plane represents an equation. So if three planes intersect at one point, that will be a unique solution. If three planes intersect on a line, like in this example, okay, then it will be infinitely many solutions. If three planes are all parallels, if three planes are all parallels, then there's no solution. So as you can see, the system of equations in three variable, some system, all the equation have three variables, but some system only have two variables. One is missing in each equation. Okay, so like before, we want to know what is the solution is going to be. So since it's in three-dimensional, the solution will be not order pair anymore. It will be order triple, which satisfy all the equation. So the first things that we want to do will be like before. We want to know how to determine the given order triple is a solution or not. So basically, you substitute into equation and check does it satisfy or not, one by one. If all of them is satisfied, then we know that it is a solution. So the first example is determining whether the order triple for -1, -5 is a solution or not. So we bring out the first equation, right? 3x plus y plus c equal to 2, and substitute the order triple. So 3 times 4 plus -1 plus -5, does it equal to 2? Question mark. So this gives us 12 plus -6 equal to 2. And you can see right away 6 does not equal to 2. If one equation is not satisfied, then we can stop. We can say that. Therefore, 4, -1, 5 is not a solution. For this system. Right? So we only need to test one if that one doesn't work. If it is work, then we need to continue testing each equation. So that's how we test it is a solution or not. Now, going back to the main thing that we want to do, which is solving the system of equation, three equations and three unknown. I would recommend you follow the structure very carefully, so that way you will not get confused. And I will point out what is the main goal that we are trying to get. So clearly, solving by graphing for this system of three is impossible because drawing three-dimensional on two-dimensional paper is a mess, trust me. So we will use either a substitution method or elimination method. In substitution method, it doesn't work for every single type of system of equation. So I would rather teach you just one method and then you can use it for every single problem, which is elimination method. So first, we want to rewrite in a standard form, meaning it's all the variable on one side and number on the other side. And then what we're going to do is we're going to choose a pair of equations and eliminate one variable. Okay, so out of 3 we choose 2 and eliminate one variable. And after that we're going to choose a different pair of equations and eliminate the same variable as we did in step 2. So that will help us to get the result from the step 2 and the result from step 3 have the same variables. And that's our goal, because only if you get to that step, the step 4 is our goal, right? Because now, like I mentioned earlier, equation from this, the result from step 2 and the result from step 3, they have the same variable, so we're going to set it up a system in 2 variable equation. And that's something that we know how to continue solving. So after we got 2 variable with 2 equations, we continue solving and then looking for the missing variable after that. So let's try to do example 1 to see this entire process. I will recommend you write down vertical down. Don't try to do zigzag, or don't try to show too many arrows, because on the test I will not be able to follow you. Okay? So first we're gonna have to decide which 2 equations I want to pick and then which variable I want to eliminate. So from this, if I look at it, I think I will eliminate Z, right? Because equation 1 and 2, if I eliminate Z, I just have to multiply the one equation by -1. And then I will choose either equation 1 and equation 3 or equation 2 and equation 3 to eliminate the same variable Z again. Right? So let's start with that plan. Now notice that you can eliminate any variable that you want. Doesn't have to be like, Z or Y or X first. Okay, so that's why like all of you will be like, going into a different route, and it's very important that you write in format so that I can follow clearly your work. So always, as usual, like I mentioned it, right, copy down the original equations that you're going to be used. So I'll copy down 3x plus y plus z equal to 2, and x plus 2y plus z equal to -3. So I will copy down equation 1 and equation 2. And then we already decided to eliminate z, so I'm going to multiply the equation 1 by -1. You can multiply equation 2 by -1 also. Okay, doesn't have to be the first equation, so a lot of variation can happen right here. So this will give me -3x minus y minus z equal to -2, and the second equation doesn't change, so it's x plus 2y plus z equal to -3. And now we added up 2 equations together, so this will give us -2x plus y is equal to -5. So notice that after we eliminate variable x, I have equation with x and y only. Now we're going to choose a different pair of equation. That's my next step. And in this case, I will choose equation number 2 and equation number 3. The process is not short, but be patient. That's what I want you to do, okay? Be patient. And then also write format. So I'm going to eliminate the same variable z, so I have to multiply the equation number 2 by -2. So this will give us -2x minus 4y minus 2z equal to 6, and 3 2x plus y plus 2z equal to 4. And you add two equations together. So this gives us x minus 3y equal to 10. So notice that the result from first and second, and the result from the second and third equations, they have both x and y. So now I'm going to use these result equations to set it up a new system, which is 2 by 2. So this will become negative 2x plus y is equal to negative 5, and x minus 3y equal to 10. That's my new system. And then from this new system, I'm going to decide to continue eliminating another variable. So in this case, I will eliminate variable x, which is I just need to multiply by 2 to the second equation. You can eliminate y by multiplying the first equation by 3. Doesn't really matter because we're going to get all the value anyway at the end. So it'll be negative 2x plus y is equal to negative 5, and 2x minus 6y equal to 20. Now added up the equations together. That give us minus negative 5y is equal to 15. So therefore my y is equal to negative 3. Now we found the value of y. And we're going to use this value of y and plug it back into equation that have two variables to look for the other one. So meanings I have a choice of choosing negative 2x plus y equal to negative 5, or x minus 3y equal to 10. So I have a choice of these two. Right? So now I'm going to choose x minus 3y equal to 10, this equation, to continue. So that will be x minus 3 times my y value is negative 3, right, equal to 10. So this gives us x plus 9 equal to 10. So therefore x is equal to 1. Now I have y and I have x. Therefore I can go back and then plug it into one of the original equation, which has 3 variables, to find out z. So I have 3 choices. I can choose the first equation, which is 3x plus y plus z equal to 2. And then substitute my x and y. So x is 1, right? And then plus my y is negative 3, plus z equal to 2. So this gives us 3 plus negative 3 plus z equal to 2. So therefore z is equal to 2. So now I have all 3 values. So you need to write your final answer in order triple, which is going to be 1, negative 3, 2, and this will be my final answer for example 2. So notice that it is a long process, but it's very systematically that you can do. And this type of problem is a full-blown process. Right? This is the first example that requires you to do a full process. So let's do the example number 3. So example number 3 is the type of question that have only 2 variables. This one is much shorter, but however, you need to remember what we are trying, what is our goal. Okay, our goal is always to get what? A system of equations 2 by 2. This portion. Our goal is to get a system of equations with 2 by 2, so that we can continue solving. Okay, so let's take a look at on example number 3. Okay, let's take a look at on example number 3. So example number 3, and in this example, I would recommend you to rewrite it this way so that you can see much clearer what's going on. So 3x minus uh, minus 4z equal to -1, and 2y plus 3z equal to 2, and 2x plus 3y equal to 6. So notice that I rewrite it, reorganize it so that I can see which equation missing what clearly very quickly. Now, like before, I'm going to try to eliminate one variable, okay, from a pair of equations. So it is your choice to choose. So for this one, we don't have much of a choice because if I choose equation 1 and 2, then I can only eliminate z. If I choose equation 1 and 3, I can only eliminate x. Or if I choose equation 2 and 3, I can only eliminate y. So if you choose equation 1 and 2, then we will eliminate z. So let's start with that. Okay, so 3x minus 4z equal to -1, and 2y plus 3z equal to 2. And we will eliminate z, so I'm going to multiply the first equation by 3 and the second equation by 4. So this gives us 9x minus 12z equal to -3, and 8y plus 12z equal to 8. And we're going to add these two equations together. So that gives us the result, which is 9x plus 8y equal to 5. Now, like I mentioned earlier, if I use equation 1 and 3, I can only eliminate y, and that will give us x and z, right, in a result. And if I use equation 2 and 3, I can eliminate y, and then again, it will give me x and z. So I don't need to go all around because I use equation 1 and 2, eliminating z. I got the result x and y. In one of our original equations, look at the third one, I also have the variable x and y. So now I can use this result and the original equation to set it up the system of equation. So that means I can right away jump down to 9x plus 8y equal to 5, and using the third equations on original problem, which is 2x plus 3y equal to 6, to set it up the system of equation 2 by 2. That's our goal. Okay, that is always our goal. So this is a lot shorter process now. So now from here, I will decide which variable to eliminate again. Right? So I will eliminate, in this case, eliminate the variable y, so multiply by 3 and -8. This will give us 27x plus 24y is equal to 15. -16x minus 24y is equal to -48. And then we add these two equations together. That gives us y eliminated. This will be 11x is equal to taking away 48, take away 15 is -33. So therefore my x is equal to -3. Now I can use this value because of the original equations have only two variables, so I can use this value x to find out z by plugging into first equation right here, right? Or I can plug it into the third equation to get my y. So starting plug it into the first equation, 3x minus 4z equal to negative 1. So plug it in x with negative 3, right? That will help me to get my z. So negative 9 minus 4z equal to negative 1. Negative 4z is equal to 8. So therefore z is equal to negative 2. So I have two answers so far. And lastly, I'm going to substitute this value x into the third equation, which is 2x plus 3y equal to 6 to get my value of y. So again, 2 times negative 3 plus 3y equal to 6. So negative 6 plus 3y is equal to 6. So 3y is equal to 12 by adding 6 to both sides. And dividing 3 to both sides, that gives me y is equal to 4. So now I have the order triple, which is x is negative 3, y is 4, and z is negative 2. And that will be my final answer for example 3. Okay. So let's take a look at on example 4. So example 4. Oh, this one is nicely done because I can see that if I choose equation 1 and 2, I can eliminate x, and 1 and 2 and 3, I can also eliminate x. So let's start with that. So equations 1, equation 2, and I can eliminate x right away for the system. So that will become 3y plus 4z equal to 8. And then I will choose equations 2 and equation 3 to eliminate the same variable. Right? And right away I can add the equations to get the result. So this will be negative 3y minus 4z equal to 4. Now I can use the result from here and here to set up system of equations, which is 3y plus 4z equal to 8 and negative 3y minus 4z equal to 4. And I don't need to do anything, and then when I added up these two equations, this gives me 0 is equal to 12. That is false statement, so therefore we know that this is no solution. From previous examples on previous sessions, this should be easily recognized at this point. Lastly, application problem. 3 equations, 3 unknowns. So we will do full step format like before. First define the variable and then setting up system of equation. So for this problem, first step I want to define my variables. Okay. So community college fine art department sold 3 kinds of tickets on the latest its latest dance presentation: adult tickets, student tickets, and children tickets. The fine art department sold 350 tickets and brought in 4,650 in one night. The number of children tickets sold is the same as the numbers of adult tickets sold. So how many of each type did the department sell? So in this case, what we don't know is the numbers of adult tickets sold, the numbers of student tickets sold, and the numbers of child tickets sold. So I can say that A, S, C. Now, like before, we're going to set it up the equation because we're using three variables, so we have to have three equations to set up. One hint that gives you is on the quantity part. Okay, one hint is on quantity. So the quantity is basically right here. It tells you the total tickets sold is 350. So that means the numbers of adult tickets plus the numbers of student tickets plus the numbers of child tickets must be equal to a total of 350 tickets. The second equation that we can set it up is on the dollar amount because it involves dollar amount, right? So the dollar amount, where do we set it up? How do we know? The total amount sold is 4,650. So that means $20 times the numbers of adult tickets sold, $12 times the numbers of student tickets sold, and $10 times the numbers of children tickets sold. These amount of money all added up together should be equal to $4,650, right? Because unit price times the quantity on each case. And last equation, it tells you the numbers of children tickets sold is the same as the numbers of adult tickets sold. So that means the children tickets C must be equal to the numbers of adult ticket, which is 80. That is basically the relation between the two types. So by simplifying a little bit on this case, it will make it easier for us to continue right here. Okay. So if I rewrite this third equation into a standard form, that will become minus A plus C equal to 0. So what we want to do is we want to choose equation 1 and equation 2, eliminate variable S. Then we will get the result of A and C, and I can use with this equation to continue. So planned it ready, so let's start solving. Equation 1, equation 2, and we're going to eliminate the variable S. So I need to multiply the first one by negative 12. So this gives us negative 12a minus 12s minus 12c is equal to 350 times with 12. That will give me negative 4,200. 28 plus 12s plus 10c equal to 4,650. And we add these two equations together to eliminate s. So this will be 8a minus 2c, that is equal to 450. Now we use these equations with the last equations on the original one to set it up the system of equation 2 by 2. So negative a plus c equal to 0, 8a minus 2c equal to 450, which I can simply multiply the first equation by negative 2, not negative 2, just 2, to eliminate c, which will become negative 2a plus 2c is equal to 0, 8a minus 2c is equal to 450. Add them up. This gives me 6a is equal to 450, and divide both sides by 6. So 450 divided by 6, that gave me 75. So now that I know a is 75 and c will be also equal to 75 because a and c's are the same, right? Adult and children. So that tells us the last equation, a plus s plus c, that is equal to 350. So my a is 75 and then my c is 75. So therefore I can find out my s, the student tickets, which is s plus 150 is equal to 350. Taking away 150 on both sides will be 200. So now finally we can interpret it. 75 adults, 75 child, and 200 student tickets were sold. And this will conclude this session.